beautiful people, and welcome. In today's video, I'm going to be going through the individual practice or your pre-test for your upcoming unit test. As always, if I make a mistake, let me know where the mistake occurs so that way I may learn from it. And I'm going to try to go really quickly, so make sure that you're pausing this video, rewinding, going back, slowing it down, because you are given 1 hour to complete this test. So I don't want this video to be an hour long. So I'm going to try to go through it quickly. However, I do want to point out key things that you need to know. All right, let's go ahead and get started with number 1. So you have 4 points that form a trapezoid. So I know I'm going to have a trapezoid. And here we're just going to quickly sketch it just so we know where exactly this trapezoid is located. So we have a point A at 0, 0. We have a point B at 5, 0. Again, we don't need to be precise. We just need an idea. Here's 0, 6, and then there's, if this is 5, 6, 7, 8, maybe 8-ish is here, 8, 6, so we have a trapezoid that looks like this. That should be on the same height. Let me make an adjustment. There you go. Okay, so we have a trapezoid with those given points. Sketch the figure that is formed by rotating the trapezoid ABCD around the x-axis. So here's your x-axis. Here's your x-axis. So if I was to rotate this trapezoid around the x-axis, meaning here it is, and I was to rotate it, pick up that trapezoid and just kind of start spinning it. So here it is. Here's your trapezoid. And we're going to, let's see if this works better. We're going to start spinning it. Here's your x-axis. And we're going to go all the way around the x-axis like this. And so our question is, what is the shape that is formed when you're rotating it around the x-axis? So what happens to this side here? When we rotate it with this side, rotate it, you can see that it kind of forms a circle here. So this, rotating this right here gives you a circle. Well, what about rotating these two things? Well, rotating these two things make it look like this. However, notice that the top portion, this portion right here, is much longer than the bottom one. So when we rotate the top portion, it kind of makes a circle, but then the inside also makes a circle. So the top portion is longer, and it kind of makes a circle. And then we have this intersection. So again, what happens to the intersection when we rotate across the x-axis? This inner circle, this inner point also creates a circle. But the inner point kind of looks like this because it's just one point. We rotate it, this one point, we have a circle here. However, it is on the x-axis. So if we look up here, this point right here is on the x-axis. This is on the x-axis, so it looks something like this. What is the radius of the new figure? Well, if this creates a reflection and this part is a circle, what is the radius of that circle? So we need to know from the x-axis to the top what is the radius. And in this case, the radius is 6. And again, a radius, so we want units, because we don't know what it is. What is the new height of the figure? The height of the figure is going to be this distance right here. So the new height of the figure is 8 units. Name the figure. We have a cylinder without a cone. Or you can say the cone has been drilled out. Let's go ahead and continue. Which of the solids studied in, so name this thing right here. And so it is a square pyramid. What is the surface area of this square pyramid? So this is where it's super important to know your sides. What I mean by that is, here is your square. Here is your pyramid. So what we have 8 here. We know that the base is actually 5. Let's do the bases. Base is 5 and 5. And then we have 8. 8 is referring to the edge. It's not referring to the slant height that we need to solve for the surface area. Now, something you need to know about the slant height is the slant height meets the side of the base at a right angle. So what do you have? Is we have to find what the slant height is, and you're looking at something like this. So you do, in fact, have a right triangle. However, you're not finding height. You're not finding the edge. You are trying to find slant height. And slant height, since it is perpendicular to the base, right here, the edge of the base, this is your slant height. This is it's in the middle, so we have 5/2 here. And then we have 8 as our hypotenuse. I'm going to go ahead and trace over that so you can see it a little bit better. We have a right triangle. Here's our right triangle. The slant height meets at a right angle. So here's my slant height. Here is the 5/2, and then my hypotenuse is 8. So knowing that, let's go ahead and find the surface area. The surface area is equal to 1/2 the perimeter of the base times slant height plus the area of the base. So let's do that. Perimeter of the base, what is the base? The base is a square. It's a 5×5 square. So the perimeter of the base is 20. Slant height, we said is what? Oh, we didn't calculate slant height. We said we need to calculate slant height. So let's do that. We have slant height squared plus 5/2 squared is equal to 8 squared. So I have slant height squared plus 2.5 squared is equal to 8 squared. Slant height squared is equal to 64 minus 6.25. I'm kind of combining steps here. So then I have slant height squared is equal to 57.75. So therefore, slant height is equal to about 7.6 centimeters. So let's type that in. 7.6 centimeters for my slant height. I'm going to erase the centimeter part. Plus the area of the base. Area of the base, 5 times 5 is 25. All right, so then let's go ahead. Let's divide that out. So I have 10 times 7.6 plus 25. This is 76 plus 25. So we have 101. So the surface area of our square pyramid is 101 centimeters squared. Make sure you have your units or you will be marked incorrect for your answer. And pause the video, look back if something didn't make sense. Next thing you have is a right cone is placed on the ends of the right cylinder as shown. Find the volume. So this time it's asking for volume. So we have a composite figure. We need the volume of a cone and we need the volume of a cylinder. Again, make sure you have your cheat sheet out for your formulas. If your teacher allows it, since we're doing this at home, you will be allowed your cheat sheet. Okay, so your cone volume formula is 1/3 area of the base times the height. And then the cylinder is area of the base times the height. So what is the base of the cone and the cylinder? The base is a circle. So we want the area of a circle, which is pi r squared. And we're doing that for both. So area of the base is pi r squared. Ooh. And then what is the radius? Radius is 5. What is the height of the cone? The height of the cone, oh, they didn't give us the height of the cone. This 13 represents the slant height. So we need to find the height. Notice how we have a right triangle here in order to find the height. So let's do this really quick. I have h squared plus 5 squared equals 13 squared. So we have h squared is equal to 25 minus, just kidding, not 25. We have 169 minus 25. So h squared is equal to 144. That means our height is equal to 12 centimeters. So let's go ahead and bring that in. 12 centimeters is the height of our cone. So then let's do this. I have 1/3 pi times 5 is 25 times 12. Simplify that. So I have 25 times 4, which is 100 pi for my cone. So now let's do cylinder. Pi radius we said was 5. What's the height of the cylinder? It is 2. So we have 25 times 2 pi. That means I have 50 pi. Now read the directions. It's asking for exact answer. That means you are not rounding and you are leaving pi. Volume, what is happening? Are we removing anything? Are we drilling anything out for volume? No, we're just putting a cylinder and having a cone on top of it. So that means I'm going to add these things. So I have 150 pi. What are we solving for? We're solving for volume. Volume is always cubed. What is the surface area of the composite figure? Give exact answer, show your work. Now the plan is just, hey, what is the plan? How are you going to go about solving this? So my plan is this. I have a surface area I'm going to need of a cylinder, and I'm going to need the surface area of a cone. However, there are things missing. So from the cylinder, here's my cylinder, and here's my cone. From the cylinder, I have missing the top portion. I can't get to it, so this top portion is gone. And from the cone, this bottom portion is gone. And the reason they're gone is because I can't reach it. Surface area is the things that you can paint, you can touch. I cannot reach this top portion of the cylinder, and I cannot reach the bottom portion of the cone because they are on top of each other. If you're not sure of how to see what is touchable and not, go ahead and watch the previous video on surface area. All right, so that means for the surface area of the cylinder, I'm going to subtract one base of the cylinder, one base area. For the cone, I'm going to subtract this bottom base. So let's write out our formulas for our surface area of the cylinder. Again, have your cheat sheet ready if you don't remember your formulas. So for the cylinder, our formula is the lateral area plus 2 times the area of the base. For the cone, we have surface area is equal to the lateral area plus 1 area of the base. Now notice that we got rid of one base area, so we're going to go ahead and get rid of that base. Notice we got rid of one base. Here's 2 bases, so I'm going to need just 1. So what do I have? I have lateral area plus 1 base area for the cylinder now. And what do I have for the cone? I simply have the lateral area. So let's go ahead and figure out what lateral area for a cylinder is. Lateral area for a cylinder is the perimeter of the base times the height. And then we have our plus base area. But what is the perimeter of the base? The base is a circle. So what is the perimeter, or what is the outside of the circle? That is called the circumference. Circumference of a circle is 2 pi r. We're going to bring down our times our height and our plus area of the base. Now let's go to the lateral area of the cone. Lateral area of the cone is 1/2 times the perimeter of the base times slant height. Now what is the perimeter of the base? Again, the base is a circle. So what is the perimeter around the circle? That is also called your circumference. And what is the circumference of a circle? It is 2 pi r. And then we have our slant height. Let's go ahead and plug some numbers in. 2 pi radius was 5. Height of the cylinder was 2. And we want the area of the base. Well, the base is a circle. So what is the area of the base? That is pi r squared. So let's go ahead and have this. I have 2 times 5 times 2. 5 times 2 is 10. 10 times 2 is 20. And we're going to add to that pi r squared. Radius was 5. So I have 25 pi plus 20 pi. And again, we're just going to add these. We're treating pi like a variable, so we can add like terms. So 20 and 25, that is 45 pi. And I'm just going to underline it because I know that value is important. Now let's go ahead and continue with cone. I have 1/2 times 2 pi r times my slant height, and in this case, they did end up giving us our slant height of 13. Notice that we can cancel stuff out. So we have just pi r is 5, and we have 13. 13 times 5. You know, I can count this using my fingers, but I'm going to choose to use a calculator for that. 13 times pi is 65. Again, underline it. Now, if you removed in the beginning what you cannot reach or can't touch, then at the end for your surface area, you're going to add always. So we're going to do 45 pi plus 65 pi, and it is asking for the answer in exact form, so that means we are not rounding and we have pi in our answer. Always remember your units. What are we trying to solve for? We're trying to solve for surface area. Surface area is always squared. All right, consider a pyramid with a surface area of this. Important information. Let me grab a highlighter. So we know the surface area is that, and we have a volume of this. If you decrease the size of the period by dividing all dimensions by 2, answer the following questions. What is the surface area of this new period? So the way I like to set up, this is a scale factor problem. So the way I like to do it is I do a little box here, something happens, and then we have another box. This is your original or your old figure. This is your new after something happened to all dimensions. So since this one's asking for surface area, let's do surface area. My original surface area was 1024. What happened? All of the dimensions were divided by 3. That means I get to multiply by 1/3. Now, I'm not just simply multiplying by 1/3 because I'm dealing with surface area. Surface area is always squared. And the way that I like to remember that, here's a thinking bubble. Whenever we have surface area, we have units squared. So for the factor is always going to be the factor squared. Very similar for volume. Volume is always the unit cubed. So that means our factor is always going to be cubed. So here's our factor. We're always squaring it for surface area. So that means I have 1/3 times 1/3. That means I have 1/9. This here is your actual factor that you're going to be multiplying by. So what do you have? You have 1024 times 1/9, and that will give you your new answer. So 1024 times 1/9, or divided by 9, and that's equal to, hold on a second, my calculator's acting up. Oh, you guys, I misread this question. You guys catch that? Yeah, I even circled it. It says 2, not 3. I don't know where I got 3 from. Let's try this again. It still works the same way, but in this case, we will have 1/4. That's a 4. I hope you guys caught that mistake before I did. I hope you were yelling at me on the screen. So it's 1024 divided by 4, and that gives me 256. Let me go ahead and highlight that with a different color so you guys see. This 2 divided by 2 is divided by 2, which is multiplying by 1/2 squared. And it's squared because surface area is always squared for our units. Make sure that you have units here. So the answer is, what's the new surface area? Well, surface area is 256. What? Puppies, children, water bottles, like what is it? 256. That is centimeters squared. Let's do the same thing for volume. Hopefully I don't make a mistake this time. So my original volume is 216. Something happens, and then I get my new. Well, what is something happened? All dimensions are being divided by 2, which means I'm multiplying by 1/2. But I'm not going to be simply multiplying by 1/2 because I know that volume is always cubed. So how do we do this? That is 1/2 times 1/2 times 1/2. So what you can do is you can also say that you have 1/2. 1 is cubed, 2 is cubed because of this 3 cubed. So that means I have 1 over 2 times 2 is 4, 4 times 2 is 8. So my factor, what I'm going to be multiplying by, is 1/8. So now what do I have? I have my original times my factor gives me my new. So 216 times 1/8, that gives me 27. 27 what? 27 centimeters. Volume is always cubed. Move on. A college campus covers an area that's shaped like a trapezoid. So we know it's a trapezoid. Here's a trapezoid. The base is 4 miles and 3 miles long, so miles, and the height of 13 miles. This is not drawn to scale, obviously, because 13 should be a lot bigger visually than 3 and 4, but that's okay. If there are 40,000 people on campus, what is the average population density on the college campus? Okay, so population density is this formula. You have your population over your area. So population is, so density is equal to 40,000 people over the area. Now we want the area of a trapezoid. So what is the area of a trapezoid? This is a formula you need to have memorized. It is 1/2 times your base 1 plus base 2 times your height of your trapezoid. So it is 1/2, 4 plus 3 times 13. So that means I have 7/2. 4, 5, 6, 7 divided by 2 times 13. Calculator time, I have 7 divided by 2 times 13. And that gives me 91/2 or about 45.5. So I have 45.5 as my area. Now here's what's important. You need to make sure that you have units. On top we have the quantity of people, the population. On the bottom we have area. Area of what? The trapezoid. But area, what are my units? It is miles and area is always squared. Now the units are super important because when you do your answer for 40,000 divided by 45.5, you get 879.121. Now, what are your units? Your units are people on top over miles squared. Now, another thing that I want to mention is this right here. For population, you always want to round up, even though if you look at it, we technically should be rounding down. And the reason we want to round up is because we can't have a 0.121 of a human, but because it is bigger than nothing, we do want to account for that not even that one, but that 0.121 part of a human being. So you want to round up for population. So we have 880 people per mile. So you have about 880 people per mile square, so square mile. All right, let's go ahead and move on. All right, sorry about that. There was a itsy bitsy spider that needed to die. All right. A conical, which means a cone-shaped candle. So we're going to be drawing a cone. Is made from 1,225 centimeters cubed of wax. So we know centimeters cubed of wax. That means we have volume. If the candle's height is 6 times its diameter, what should the radius be and the height, both accurate to the nearest tenth? That means 1 decimal place. Okay, this one, in my opinion, if you want to put a star next to it, this one is one of the more difficult problems because there's a lot going on with it. I think this one and maybe number 11 or 12 or 13 is another difficult one. We'll get to that. Okay, so since height is 6 times its diameter, that means height is 6 times something else. Now, this something else is what the diameter is equal to because we have a diameter. So what diameter is equal to? Diameter is 2 times its radius. So I'm going to put 2 times its radius. So that means my height is equal to 12 times the radius. So it's asking us what in fact is the radius and what is the height. So going from here, I'm going to put that in a bubble, kind of separate it out. I'm going to say, here's the volume, and I know what the volume of a cylinder is by looking at my cheat sheet. Volume of a cylinder is pi r squared, so the area of the base, times the height. Do I know the height? Do I know the radius? So I don't know either of them. So I have an equation here with two unknowns, r as an unknown and h as an unknown. So you can only solve an equation with one variable. However, we already said that the height is 12 times the radius. So I'm going to substitute, I'm going to replace h with 12r. So now I have one variable, and that variable is r. Now you have options here, what you'd like to do. You can multiply things out. So if you were to combine all of this, you have 12, you have pi, and then you have r squared times r. R squared times r is r cubed. So you're going to then divide. Now, how are all of these attached? You have 12, you have pi, you have r cubed. All of these are attached by multiplication. How do you undo multiplication? You're going to divide. You're going to divide by what? Well, you're going to divide by whatever you don't need. So I need to keep my r, so I'm going to circle it. We don't touch that. Everything else is attached by multiplication. So everything else we get to undo by division. So I have 12 and I have pi. I'm going to divide by that. My pi's go away, my 12s go away, and 12 pi is just a number. I don't know what that number is, but my calculator does. So I'm going to say 1225, so 1,225 divided by. Now, here's another thing that your calculator is going to make you get the answer wrong. Don't depend on the calculator too much. If you don't put this in parentheses, sometimes your calculator will misinterpret what you write. So make sure that your denominator is in the parentheses for 12 pi and use the pi button, not 3.14. That will give you the wrong answer. And I get an approximation of 32.4941, and that's equal to r cubed. So how do you undo that? Well, this is just saying r cubed, so we need to undo r cubed by cube rooting both sides. This 3 and the other 3, right here, this 3 and this 3, they go away, so we just have r. So how do you type this into your calculator? Now, unless you have a fancy calculator, you're going to have to rewrite this in terms of an exponent. So what you're going to do is you're going to say 32.4941, put that in parentheses, and you're going to raise that to your calculator. So put a caret there for your calculator, and you're going to raise it to the 1/3 power. That is the same thing as saying cube root. So we have 3241, and that's raised to the 1/3 power, and that gives me an approximation of something went wrong. Hold on a second. I am going to try, make sure that my calculator didn't misinterpret things. Oh, you guys, you notice that? I went off of the wrong formula. I'm like, why is this not working out? It should work out. Okay, I'm happy I used pencil. And again, I apologize. Hiccups happen all the time. Make sure you're using the right formula and learn from my mistakes. This formula that I got was for a cylinder. What do we have? We have a cone. I hope you were yelling at me in the beginning when I drew that cylinder. That's not a cylinder. We have a cone. A cone. Shame on teacher. That's okay. I will learn eventually. So then how does my formula change? Well, I'm really happy that the only thing changes to my formula is I have a 1/3 here, I have a 1/3 here, and I have a 1/3 here. So that means when I divided by 12, I didn't have a 12 really. What did I have instead of a 12? Well, I have a 12 and I have a 3. So I have 12 divided by 3. That means I had a 4, not a 12. So I'm going to divide by 4 and not 12, which means this number right here is, so I have 1,225 divided by, again, parentheses, 4 pi. And that should give me 97.4824. So then let's get eraser. So we have 97.4824 raised to the 1/3 power. Beautiful. And that gives me 4.6. Again, we're rounding to 1 decimal place. Sorry about the hiccup. It's a cone, not a cylinder. I used the wrong formula. So when you use the correct formula, it gives you the right answer. So here's my radius. Now, what did we know about the height? We knew the height was 12 times the radius, which means I have 12 times 4.6, which gives me 55.2, again, rounding to 1 decimal to the tenths. And then make sure you have your units. So radius is singular, so I have centimeters. Height is singular, so I have centimeters. All right, let's go number 10. You have a lead ball with a mass of 420. Let me change that to a pencil. We have a mass of 420. You have a density of 10.5. What is the volume? So we know density is equal to love, which means density is equal to mass over volume. Now, we don't want to solve for density. This formula has us solving for density. What we want to solve for is volume. So that means you have to get volume, the V, by itself. So how do we get V by itself? Well, V is in the denominator right now. So I'm going to multiply by V to get it in the numerator. That means I now have V times D is equal to my mass. I solved for mass, but I don't need mass. I need volume. So I'm going to go do this one more time. I'm going to divide by D both sides, which gives me my volume is equal to my mass over my density. So what I have here is I have volume is equal to my mass is 420 grams. My density is 10.5 grams per centimeter. And again, I'm doing this on purpose. For my units, you need to make sure your units. Notice they have a G on top and G on the bottom, which is on top. So your G's go out. So I have 420 divided by 10.5, and that gives me 40. The units that are left over are your units for your answer, which are centimeters. And what are we solving for? We're solving for volume. Volume is cubed. Ooh, you didn't see that. There you go. This one kind of cut off when I printed it. So given the surface area of a cone is 50 meters squared. Now I have to turn the page. So surface area is 50 meters squared. Radius is 3 meters. Approximated slant height to 3 decimal places. Okay. So we know surface area is 50. We want slant height. So the only formula that has slant height is the surface area of whatever this is. So what is this? Again, it cut off. Let me see here real quick. It is cone again. Let's see if I can actually get the formula right this time instead of my hiccup on my last problem. So the cone surface area is the lateral area plus the area of the base. Lateral area of a cone is 1/2 times the perimeter of the base times its slant height plus the area of the base. the perimeter of the base is my circumference, which is 2 pi r times my slant height plus the area of the base. Now we're going to simplify that formula because I have a 2 on top, 2 on the bottom. So that means my surface area of a cone is pi r times my slant height plus the area of the base. Now, what do we need from there? What's the whole point of this formula? Well, we're trying to solve for my slant height. So I need to know what the area of the base is. Well, the area of the base is a circle. So what's the area of a base? That is my pi r squared, area of a circle. Notice I only have one unknown, and that is my slant height because they give us radius. So what do I have? I have pi, radius is 3 times my slant height plus pi, radius is 3 squared. So I have 3 pi times my slant height plus 9 pi. Okay, this is all equal to whatever your surface area is equal to, which is 50 meters squared. Now, you have two terms here. Here's one term, here's two terms. You have to get rid of the term that does not have your unknown in it. So 9 pi does not have slant height in it, so we need to undo 9 pi. How do I undo a positive 9 pi? I'm going to have a negative 9 pi because we're doing the opposite. So negative 9 pi on both sides. Here's your side. Make sure you do this dotted line on a problem like this because sometimes you end up subtracting or adding things double on one side. You can't do that. So we have to subtract 9 pi. Now 9 pi is simply a number. I don't know what that number is, but my calculator knows it. I have 3 pi times my slant height left over. 50 minus 9 pi, calculator time, 50 minus 9 pi is about 21.7257. Now we're not done because we still have to solve for our unknown. Our unknown is my slant height. So slant height is attached to two other things, 3 and pi. How are they attached? By multiplication. How do we undo that? I'm going to bring that up here. We have to undo that by dividing both sides by 3 pi. Now again, your calculator will misinterpret this. Make sure you put the denominator in the parentheses. So I have my slant height is equal to all of that. Make sure you're using parentheses in the denominator. And we have my slant height as 2.305. Now we want the answer in 3 decimal places, so make sure you're rounding accordingly. So my answer is 2.305. What? Puppies, children, kittens. Let's look at our units. Our units are meters. Slant height is singular. So we just have 2.305 meters. All right, now moving on to number 12. We're trying to find the surface area of this solid. So step number 1 is always to name what we have and then write down the formulas and then figure out what we have and don't have. So let's see. We have a rectangular prism. And we have a triangular prism. Now it is not a pyramid because we don't have things lining up to one particular point. Notice that there are different points for a pyramid. All of the sides or lateral faces, they meet up to one point. We don't have that. Right. Rectangular prism. Notice that we have a shared side. So here's your rectangular prism. And what is shared is this guy right here. And so for the triangular prism, what we have shared is this guy right here. So whatever is shared for surface area, you have to remove that. Now it is your choice if you want to make the red thing your base for a rectangular prism. Because for a rectangular prism, you choose which one you want your base to be. So if I wanted to make the red piece my base, all I'm going to do is I'm going to take this rectangle and shift it up so it looks something like this. I'm trying to figure out how to put it to where, oh, I think I know, like this. Like that. Then this piece is the shared piece right here for your rectangular prism. So if I make this my base, let's figure out what my base is in measurement. This side would be 5. This side would be 11. So then my height would be 12.5. All I did is I took this rectangular prism and I stood it up in order to create the red piece to be my base. And the reason I want to do that is because when we write out our formula, we now know we need to subtract one base, and we can only do that if we pretend to stand that rectangular prism up. You can't assume that this bottom piece is your base and then subtract that base, because you would be subtracting the wrong thing. Make sure that you're subtracting the correct area. All right, let's talk about surface area formulas. So surface area of a prism is the perimeter of the base times the height of the prism plus 2 times the area of the base. I'm going to write that formula twice since we have a triangular prism. And all that means is the formula is exactly the same, except now when we have the perimeter of the base, our base is just now different. All right, so what do we need to get rid of? I need to get rid of one base, so I have only one base. Here, we'll talk about the triangular prism a little bit later. So then let's work with our rectangular prism. What is the perimeter of the base? Well, what did I say my base is? Here's my base, and I have an 11 by 5. So 11 by 5, 11 by 5. So I have 11, 11, that's 22. 5 and 5, that's 10. So I have 32 as my perimeter base. Now what is my height of the prism? The height of the prism is 12.5. I am adding to that the one base area, just one, and that would be 11 times 5, which is 55. So I have calculator time. Where's my calculator? No idea. I had it right in front of me. No, I don't. Oh, there it is. Okay, so we have, what do we have? 32 times 12.5 plus 55. I have 455 as my surface area, feet if you want to be fancy, for the rectangular prism without one base, assuming the base is this rectangle right here, which is also notated here. We're lifting up the rectangular prism. Now let's talk about the triangular prism. Here is your triangle. Remember, the name tells you what the base is. The rectangular prism is, the base is a rectangle. For a triangular prism, the base is a triangle. So notice that we have the base of a triangle. However, again, I'm just getting the measurements from here. There's 13, 12, and this is 5. The base of the triangle is not what is removed. It is this side that is removed. So be extra careful on that. So what is the perimeter of the base? We have 5 plus 12 plus 13. That is 30. What is the height of the prism? The height of the prism, again, if this is our base, this is our base. The height of the prism is 11. I'm going to add to that 2 base areas. So I'm going to add to that. Let me write 2 base areas. Well, what is the base? It's a triangle. What is the area of a triangle? It is 1/2. Base times height. So area of a triangle, that is 1/2. Base times height. I'm just writing, whoop, so you guys can see. All right, so then what is my base? My base is 12. What is my height? My height is 5. So my 2's get to cancel out right here. We're going to undo that. So 30 times 11, that is 330. Plus 12 times 5, that is 60. So I have 330 plus 60, which is 390. However, this is not your triangular prism surface area. We have this side to get rid of, remove, subtract. It's been removed. So we need to subtract this area from your triangular prism. Well, what is this area? What do we have? Well, we have a rectangle that is 11 by 5. What is the area? How do we find out an area of this rectangle? The area of this rectangle is just multiplying. So the area of this rectangle is 55. So I need to subtract 55 from here. And the reason I'm doing that is because that has been removed. So I have 390 minus 55. I have 335 feet squared. Again, what are we solving for? Surface area of the prism with a triangular base. Now, if you have subtracted already everything that you've removed at the end for surface area, you're always going to add. So I have 455 plus 355, and that gives me 790 as my total surface area of the composite figure. What are my units? Feet. What am I solving for? Surface area. Surface area is always squared. This is more of a difficult problem, you guys, so make sure you rewatch this, make sure it makes sense what I'm saying for every step. If you have questions, please reach out. Number 13, if the volume of a sphere is 364 pi centimeters cubed, find its surface area. So we have volume. Volume is given. We need to find surface area of a sphere. So what is the surface area of a sphere? Surface area of a sphere, cheat sheet, surface area is 4 pi r squared. Now what is given? We are given the volume. The volume of a sphere is 4/3 pi r cubed. Don't let the square and the cube confuse you. Just use your cheat sheet. So in order to solve for the surface area, I need to know what my radius is. I don't know my radius. However, I have one unknown in this formula here, so we're going to solve for radius. 364 pi is equal to 4/3 pi r cubed. Now, how do you get rid of a fraction? You're going to multiply by a reciprocal. Reciprocal is just multiplying by the fraction, and you're going to take those two numbers and flip it. So I'm going to multiply by 3/4 both sides. My 3's cancel out here in the denominator and numerator. My 4's for numerator denominator. So what is left over? I am left over with pi times r cubed. On this side, I have 364 times 3 divided by 4. And I get 273 pi. I'm going to divide by pi because I need to remove everything. I need solving for my radius. So that means my pi on top, pi on the bottom cancel out on both sides. So I have r cubed is equal to 273. Now again, what am I trying to do? I'm trying to solve for r. R is being cubed. How do I undo that? I'm going to cube root both sides. Unless you have a fancy calculator, you're going to have to do this. Put 273, whatever your base is, in your parentheses. You're going to do the caret, and then you're going to raise that to the 1/3 power. So you have 273 to the 1/3 power. We're going to approximate that. My radius is about 6.487. Now it's asking for the exact answer. So you look here, exact answer. So I actually don't need to do this. So I'm going to go back and I'm going to erase. I did too much work. If you learn anything in this class, is learn how to read the directions. So I need to follow my own advice. So it's asking for exact answer, so that means I am not rounding. I typed into the calculator cube root of 273 and it gave me 6.487. I can't round. That is not the exact answer. Therefore, this right here is my radius. Now it looks ugly, I know, but that's okay. It still wants to be loved. That's my radius. You're going to take this value right here and you're going to substitute it into r. So for this question, it's not asking you for a pretty answer. It's just asking you for the answer. So you're going to take that, you're going to plug it in as if it is a number, which it is. It's just not exact. And then you're going to square it. So surface area is this right here is your answer in exact form. Don't type anything into your calculator when it's saying exact form. Don't do it. That is your answer. This is your radius. Let me actually highlight that in a different color so that way you don't get confused. This is your radius in exact form. And that's your answer. All right, let's do last one. This is the perimeter. What is the perimeter of the horizontal cross section? So horizontal cross section means you are moving left to right. Up and down is your vertical. So if I was to take a really sharp, razor and then cut this horizontally, open it up, what would the shape be? The shape would be looking like something like this. And we're asking what is the perimeter? So if I start here and I start walking, what is the total distance? Well, they give me that the distance of this section of the cylinder is 9. So they already gave me that, 9 millimeters. They gave me that I can't use this whole thing because it starts to kind of curve. So I need to know what this section is. And I need to know what this section is. The top and the bottom are both 9 centimeters, and I got that from here. So how do I find out this section? Well, let's go back and see what we have. We have a hemisphere. A hemisphere is just half of a sphere. So if I wanted to know the perimeter around a sphere, which is just the perimeter around a circle, if we do 2D. So perimeter around a circle would be the circumference. So what is the circumference? Circumference is 2 pi r. But we don't have a circle. We have a hemisphere. That means we have a semicircle. So what is the perimeter around the semicircle? That is half of a circle, which means I'm going to divide by 2 and just pi r. So do I have a radius in order to find out what this is? And if I'm looking here, they tell me I have a diameter of 5. So that means what is my radius? That means my radius is half of that, which is 5 halves. Now 5 halves is simply 2.5. So for this section here, I have 2.5 pi, and for this section, I have 2.5 pi. Now again, what is the question asking you? What is the perimeter? So what is the total distance around this entire shape when it has been cut horizontally? And that is 2.5 pi plus 2.5 pi plus 9 plus 9. We're going to round that, and it says thousands. Tens, hundreds, thousands. That means 3 decimal places. So that means I have 33.708. What are my units? Millimeters. What am I trying to find? Perimeter. Perimeter is singular. That's it. That's your test. Your questions are going to be extremely similar to what we have here. Again, I apologize for some of the hiccups I have. It is very early and I still haven't had my coffee, but I wanted to make sure I have this video out for you so you can do really, really well on your test tomorrow. Reach out if anything doesn't make sense. As always, thank you so much for watching my video, and I will see you in the next one.